This is chapter 13, professor from Accounting 711, George Smelsley. So this chapter looks at 4 different cost management tools. Target costing, which is used usually at the beginning of product lifecycle. Theory of constraints, which is used generally for bottlenecks. Lifecycle costing, which looks at costs over the whole product. Like, for instance, we might allocate research and development costs over the life of the product rather than just expensing them as incurred, as we do in financial accounting. And then strategic pricing. So target costing, let's look at that first. And this is used normally in the design stage. And the reason is because most costs have basically been committed by the design phase. So the target cost has a very easy formula. It's just your price, market price, less any desired profit that you have. So the more complex part, really, the target costing is, if we don't have, we're not able to get to a desired profit because we can't meet the competitive price, then you're going to need to reduce your cost. And the tricky thing, or the hard part, is you cannot reduce functionality or quality. All right, so a couple things we can do to get to this price, this competitive price. Let's say it's 80 and we're at 100. So we can integrate new manufacturing technology, okay, or and that will give us higher product productivity, or we can possibly redesign the product. So those both are expensive outcomes, and that's why the target costing is normally done before we've built even one single product. All right, so it's a good way to trade off between functionality and cost, but of course you want your functionality to be in line with your competitors. So there's 5 steps. Determine the market price, so that's probably pretty easy. Determine desired profit, that should be easy as well. Calculate the cost, that's easy, but the last 2 are hard. Use value engineering to find ways to reduce costs, and then use Kaizen or operational control, say standard costing system, variance analysis, to reduce the cost even further. So here is an example I provided for you. Two Shaft manufactures a wide variety of parts for boating, including the boat engine. The component is purchased by the original equipment manufacturers such as Mercury and Honda. So Mercury and Honda, in other words, would be our customers for use in larger and more powerful outboards. So the unit sells for $660 and sales volume averages 32,000 units per year. Recently, though, our competitor lowered their price to $590. So that's really going to be the new target price. The target price is that competitive price of $590. Market was competitive, and Two Shaft realized it had to meet the new price or lose market share. So we have this data from the most current year. We have raw material labor and indirect labor, which is overhead. And then we have, and these are the actual costs for those. And then we had some material handling, some inspection, some material handling, machine setups, and then returns and rework. So these items, other than the returns and rework, would be considered overhead, right? From indirect labor, inspection, material handling, material setup, and even rework would be considered overhead. Of course, a return would be expense to the income statement. So what is our target cost? So the current cost is $466. Sorry, I'm going back here. And we find that by simply taking our total cost and divide by units. Remember in the problem, I think I bolded it. In the problem, it was 32,000 units that were produced. So my target cost is $466.61 by rounding it. So then my profit would be the $660. So this up here at the $660 minus the $466.61, 193.39. So that's our current profit, but we're not probably going to be able to hold that $660, right? Our competitor is at $590, so our OEMs are going to go to that competitor pretty soon, sooner rather than later, as soon as they get out of our contracts. But that allows us, though, to address the profit issue. It's 193.39. So our target cost then would be my new selling price of $590 less my desired profit of 193.39, so 396.61 would be my target cost. So my new target cost, in order to keep my current profit of $193.39, the cost of that product is going to have to will have to be reduced to $396.61. So we may have to use some tools like value engineering, so that basically re-engineering our product, perhaps looking at a teardown analysis of our competitor, finding out how they have reduced their costs. So we have some engineers in class, probably more familiar with this than an accountant would be. But it's basically looking at engineering to have a new functionality and lower the cost. So product functionality talks about the trade-off, and we want to be careful that our functionality is going to be the same as that competitor who is selling it right now at $590. All right. Target costing can be worked with Kaizen, so continuous improvement. So this is once the product is being built, the new product is being built, and we can find some ways to reduce costs by looking at continuous improvement processes. QFD, quality functional deployment, will be the integration of value engineering, marketing analysis, and target costing to assist in determining which of our components should be targeted for redesign or cost reduction. Right? So our product has a number of different components. We may not need to redesign all of them, but we're going to look at the ones in QFD. We're going to look at the ones that are ripe for redeployment. Those would be the ones that, if I can reduce their cost, I'm not going to lose any quality in the product or any functionality. All right, second tool in the chapter is the theory of constraints, and this is used in accounting for bottlenecks. All right, one approach we use in measuring TOC is to measure what's called the manufacturing cycle efficiency, and that's simply your processing time divided by total cycle time. All right, some of you may have read the book called The Goal, and in The Goal they discuss in detail how to do a theory of constraints analysis, and I gave you the steps here. Identify what the constraint is. Usually it's going to be a bottleneck machine, and in a plant it's going to be this bottleneck machine where there's a lot of work in process in front of that machine. Determine that product mix that's most profitable given the constraint. So if we have only so many raw materials or only so much capacity, which products give us the most or highest contribution margin per raw material or per labor hour, if that's what our constraint is. All right, find ways to maximize flows through the constraint. Try to make the constraint better, improve that constraint. One thing talked about in the goal was a drum buffer rope system, so trying to keep all processes equal from machine to machine so we don't have a lot of buildup in front of those bottlenecks. Actually, keep the process basically as quick as your slowest machine. Maybe if you can add capacity to the constraint. In the book, The Goal, they actually bought an old machine or brought back, I think, a couple of old machines to increase capacity, and then redesign your manufacturing process for flexibility and faster cycle time. So if you have the resources to do that. This is an example of QFD, quality functional. This is an example of maximizing the flow through the constraint and trying to have the most profitable product per constraint that we're building. So if it's raw materials, that's the problem, then we want to find the highest contribution margin for raw materials. All right, so that's actually B, determine the most profitable product mix given the constraints. So we're working on, this example really is looking at B. All right, so I've got two products, simple product and advanced product. And if you're looking at them, you say, hey, build more advanced products. You don't have excess capacity. You're selling everything you're building. Build the advanced product because their contribution margin is $20.50. But when you examine further, say, well, what's the contribution margin per constraint? Raw materials is my constraint. And it takes 3 pounds of raw material to build simple and 5 pounds for advanced. So if I can divide my contribution margin by each pound of scarce raw material, I'll find my contribution margin per constraint. I have a higher contribution margin per constraint for simple product Since I can't build these products without this raw material, I'm going to focus on maximizing my contribution margin for that constraint. So I'll sell as many simple products as possible. Anything left over will be an advanced product. All right, so I think the rest of that I'm going to let you read. Pretty short lecture today. So have a good week, and probably see you in the discussion boards or in the email if you have any questions. Let me know. It's I think, a pretty easy chapter and pretty easy assignment, but that's me looking at it, so it might be different for you. All right, have a good week. Thank you.